You know what's funny? People are out there arguing, really fighting about whether ChatGPT is intelligent. One side says it's thinking, it's reasoning, it's gonna take over the world. The other side say, nah, it's just autocomplete. It fancy spell checker. And here's the thing, they both are missing the point. Because today I want to show you something that blew my mind when I first understood it. Autocomplete is way more powerful than anyone give it credit for. And once you see why, you will never look at these things the same way again. Alright, let's start with a dangerous question. What does it mean to understand language? No, really. Think about it. When you speak English, when you are in the middle of a sentence, what actually happening in your head? Are you flipping through grammar textbook? Subject, verb, agreement, you know, pass. No, right? That's ridiculous. You would never finish a sentence. Are you doing probability calculation, running statistics? Of course not. So what are you doing? You are predicting. That's it. You're predicting what makes sense to say next, based on everything you have heard and read and experienced in your entire life. You have observed so much of language, conversation, books, movies, tweets, arguments with your siblings that your brain just knows what fits. And here's the wild part, that's exactly what an LLM does. It's a machine that has read so much text, we are talking about trillions of words, that it learned the pattern, the rhythm, the dance of how human continue sentence. No magic, no ghost in the machine, no tiny person in the computer, just pattern all the way down. Okay, let's make this concrete. I'm gonna shrink this problem down to something stupid and simple. Complete this sentence. The sun rise in the east, right? Obviously, the sun rise in the east. Now here's my question. Why did you know that? Did you think about astronomy? Did you calculate the Earth's rotation? Did you reason through physics of the planetary motion? No, you just knew because you have seen that sentence patterns 1,000 times. The sun rise in the east. It's burned into your brain from repetition, and that's the entire game. An LLM is doing the exact same thing, but with maths instead of neurons. Given all the words so far, it asks what word is most likely to come next. Here's the formal definition. An LLM is a neural network trained to predict the next token in a sequence. That's it. That's the whole thing. Everything else is details. Oh, wait, what? I said token. Okay, so what is a token? See, computer don't see word the way you and I do. They can't just read. They need to chop text into small pieces. These pieces are called tokens, and they are weird. Sometimes a token is a whole word, like the, hello. Sometimes it's just a punctuation, a period, a comma. And here's where it gets interesting. Sometimes the word get chopped up. Take the word unbelievable. To you and me, that's one word. To computer, it is un, chop, believe, chop, able. 3 tokens, right? Why? Because the machine learned that these pieces show up all the time. Un at the start of a word means not. able at the end means capable, right? So instead of memorizing every possible word, which would be infinite, it learns the building blocks. This is actually genius. It means the model can handle words it has never seen before. You could make up a word uh, right now. Let's say we say, see, and it's able to create a version of a tokenized version that it would in future use to try to figure out what makes sense, right? um, Given all the tokens so far, which token comes next is all the game that it's trying to play. But then to understand that, it needs to memorize a lot of word, and understanding and memorizing all word doesn't make sense, right? So it actually divide the word into small tokens and memorize the meaning of those tokens. Now what a token means to you and me might be totally different than what an AI looks for, right? So a token for it could be alpha, but it will make sense for it to use it in different contexts, right? So we should not try to understand what that specific token means or how it has divided it, but it's more or less trying to make sense of a big word and trying to understand how it can best utilize in future. um, the bottom line is, here's what I want you to understand. The entire game, the whole game is just asking, given all the tokens so far, which token comes next? That's the only question the model is trying to answer here. Okay, all right, now we got to talk about probability. Don't panic, this is easier than you think. Imagine I've got a dice, normal dice, 6 side. If I roll it, what's the chance I get a 3? 1 in 6, about 17%. Each number is equally likely, right? Language is like a dice too, but a weighted dice, a rigged dice. Some words are way more likely than others, depending on what comes before. Let's say I give you peanut butter and, right? So what are the probabilities, right? Jelly will have a very high probability. Quantum mechanics will have a very low probability, right? Jam maybe have like maybe jam could get a 8% probability and jelly might have like 85% probability. But you and me can agree that quantum mechanics really doesn't make a sense, right? So the model has this massive vocabulary, tens and thousands of tokens, and it assigns a probability to each one. Every single possible next token gets a number. But here's the thing most people miss: the model doesn't pick the right answer, it doesn't know what's right. It samples from these probabilities, it rolls the weighted dice. That's it. That's why the same prompt can give you different answer. That's why there is a temperature setting. It controls how wild the dice rolls are. Low temperature, play it safe, pick the obvious word. High temperature, get weird, take risk. Peanut butter and existential crisis. Okay. Here it's will get a little spooky. If you just predict the next word well enough, intelligence actually start to leak through. Wait, what? How does that work? Think about it. What is logic? Logic has a pattern. If A, then B, and A is true, therefore B is true. That's a pattern. It shows up in text all the time. What is reasoning? Step by step, right? Step by step thinking. First we identify the problem, then we figure out what are our options, and finally we decide, right? That is also also a pattern. What is a code? Right? Code is also pattern, right? Every for loop, every function, every if statement, it has a template, right? So here is a big insight. Language is compressed record of human thought. Everything we have ever figured out, science, philosophy, math, poetry, how to argue with your mother-in-law, it's all got written down. It's all become language. So when you train a model on a language, you're not just teaching it grammar, you're teaching it shadow of reasoning, the echoes of logic, the fingerprints of human thinking. Not because the model thinks it doesn't. Model doesn't think, but because thought leaks into language, like coffee through a filter. The model doesn't understand coffee, but it's seen so many coffee stain that it knows exactly what shape they make. All right, time to kill some myth, because there's a lot of nonsense out there. An LLM does not understand meaning the way you do. You know what a sunset feels like. You have experienced cold. You have a body that gets hungry and tired and excited. The model has none of that. It's just pattern, right, in numbers. An LLM does not have intentions. It's not trying to help you. It's not trying to trick you. It has no goal. It's just answering the question, what token comes next? And LLM does not know what's true. This is huge. It doesn't fact check. It doesn't have a truth detector. It just knows what sounds true, because based on the patterns that it has learned. And sometimes confident sounding nonsense has the same pattern as confident sounding truth. But here it what it does do. It models statistical patterns freakishly well, better than any system we have built. It generalizes, show it few examples, and it can handle variations it has never seen before. It simulates reasoning when the pattern supports it. By the way, the key word here is simulate. Think of it as a fun house mirror. It reflects everything humanity has written, but wrapped, blurred, refracted through probability. Sometimes the reflection is amazingly clear, sometimes it is nonsense. Knowing the difference is your job. Okay, I want to leave you with a mental picture, a way to think about this. Imagine a library. The biggest library in the universe. Every book, every article, every tweet, every conversation ever written down. It's all there, trillions of pages. Now imagine a librarian, but not a normal librarian. The librarian has just memorized every pattern in every book, every sentence structure, every way human transition from one idea to the next. When you ask the librarian, ask a question, the librarian doesn't understand your question. The librarian doesn't know the answer. Instead, what the librarian does is very remarkable. They scan everything they have memorized at light speed. They find patterns, similar patterns, and they predict what words usually come next in the situation like this. The librarian doesn't understand a single word, but the librarian gives good enough answer. That's what an LLM does. And once you see it in this way, everything else makes sense. The mistakes make sense, the brilliance makes sense, and the weird inconsistencies, they also make sense. It's not magic, it's not consciousness, it's not a person. It's the world's most sophisticated pattern matching librarian. Okay. If I stopped you on the street right now and asked, what is an LLM in one sentence, could you answer? Take some time, formulate your answer. Okay. Here's the answer. An LLM is a neural network trained on massive text data to predict the next token based on probability. Neural network, massive text, next token based on probability. That's the foundation, that's the bedrock. You can look at the formula here, where you LLM equal to neural network. So What is LLM build on? Build of neural network. It has learned, everything that it has learned. It has learned everything based on massive data. And what does it do? It just predict the next token. That's it. If that sentence feels wobbly, go back, watch this again, let it sink in. If it feels solid, good, you've got the foundation. Now we can build on it. Because here's the thing, once you understand this, you stop being mystified, you stop being afraid, you start seeing these tools for what they actually are. Not magic, not monsters, not saviors, just really, really good pattern matchers. And that's, my friend, is way more interesting than magic anyway. Okay, I'll see you in the next one.